Welcome back to another AP Chemistry Crash Course made by Jonathan and Earl. This will be episode 22 on our series.
Because we obviously made videos before this one.
Today we'll be returning to the topic of thermodynamics.
This time we'll be learning how to determine the final temperature of two different substances, such as water and metals. So let's begin.
Back in episode 20, we went over this formula, Q equals mc delta T.
If this formula looks unfamiliar to you and you think it has something to do with the Illuminati, assume you are completely wrong and go back and watch episode 20, which totally exists.
The letter Q corresponds to heat in joules.
The M represents mass in grams of any substance, like water or metal.
The C with a little s on the end means specific heat capacity, or the amount of energy required to heat up 1 gram of a substance by 1 degree Celsius.
Delta T stands for the change in temperature before and after the heat transfer in degrees Celsius. To solve for delta T, subtract your final temperature with your initial temperature to find the change in temperature.
Now to solve for the final temperature, we need to know that Q, or heat of the metal, is equal to the negative Q of the water, or Q equals negative Q. Q equals negative Q means that the heat released by a substance is equal to the heat absorbed by the other substance. Since Q equals negative Q, then mc delta T equals negative mc delta T, and we can solve for the final temperature with this.
And now we will demonstrate this transfer of heat with a real-life experiment.
What is that metal?
I think that metal is dangerous. As we can see, the temperature of the water started at a chilly 43 degrees Fahrenheit and skyrocketed to a scalding 55 degrees Fahrenheit. While we've been watching our experiment, our trusty chemists have been creating an example question.
A sample of aluminum is 41.6 grams and initially at 63.7 degrees Celsius. The aluminum is placed in 123.6 grams of water initially at 18.7 degrees Celsius. What is the final temperature of both substances at thermal equilibrium? The specific heat capacity for aluminum is 0.903 and the specific heat capacity for water is 4.18. Use the equation mc delta T equals negative mc delta T. Then plug in your numbers, metals on the left and water on the right. Remember delta T is equal to the final temperature minus the initial temperature. So since you're trying to find your final temperature, that will be your x variable. Now use your algebraic abilities to find x.
Well, it seems like we're out of time.
If you need any more help or examples, go to our official website, www.chemistrybs.org, by clicking on the link below.
Next week we'll be covering solutions, so we'll see you then.